Hello everyone, good evening. Okay, today we are going to talk about Snowflake. Snowflake. It is an emerging cloud-based data warehousing solution. In recent times, it has become very popular. Let us understand about this Snowflake. You can see here, this is the Snowflake's architecture diagram. Imagine you are managing data for your company. See, in your company, you have lot of data, sales records, user logs, and even JSON files from various applications. Now, you cannot work with them seamlessly when you are saving all the data into the databases because you have to segregate them before you put them into databases. Some will be structured, some will be semi-structured. Sometimes you will also have unstructured data like images, audio, video, right? It will be good if you have a one platform which can store all kind of data, structured, semi-structured. Of course, for unstructured, you can choose a different kind of data. Right now, Snowflake supports both structured and semi-structured data. Yeah, Snowflake is a platform which allows you to save your data, all of your data. That's why it's called as a data warehouse. You can save all of your data on one platform, and that too structured data and unstructured data. First, let us start understanding the Snowflake architecture. Snowflake has become very popular because of its architecture. Data warehouses are not new to the market. How Snowflake had its presence unique is through this architecture. If you see, there is a storage layer, compute layer, cloud services layer. Storage layer of Snowflake can run on top of any storage of different clouds. Right now, Snowflake is compatible with AWS, Google Cloud, Azure. That means it can take the base storage as AWS S3 bucket, Google Cloud GCS, that is Google Cloud Storage, and Azure Blob Storage. Also, they are calling it as Data Lake Gen 2. So, using these storages as base, Snowflake can build its storage layer. It can build its storage layer on top of this. And also, Snowflake anyways has its own storage layer. If you don't want to go with this, if you want to build your entire thing on the Snowflake, yes, Snowflake has a storage layer. No, you already having your storage in AWS S3 or Google Cloud GCS or Azure Blob Storage. Yes, you can seamlessly bring your data into the Snowflake. And after bringing data, what you can do with that? Variety of data you can bring in. Structured data, that is your data is CSV format or your data is in Parquet format, or you extracted data from your relational database services like MySQL, PostgreSQL, all kind of data you can bring in here into the storage. And also semi-structured data like JSON, AVRO, Parquet, these kind of data you can bring into the storage layer. Now, not only just storage, you also have a compute layer in Snowflake. What it does, it brings your data on your request, of course. The data you requested will be brought to the cache, which is nothing but memory. And there, using distributed computing, using multiple virtual machines on this memory, you can process your data so that the compute layer process your data really fast. And okay, how I'm going to process my data, pre-process the data here? Compute layer here in Snowflake supports multiple languages. It supports Python, it supports SQL, it supports PySpark. You can choose any of these languages and you pre-process your data. Once you pre-process your data, you can again save your data in the Snowflake in another table. Let us consider an example. you have a JSON data that is coming from IoT sensors. It is a JSON data. It doesn't have a strong structure, but it has a structure, semi-structure, key value pairs. Now you'll bring in that data into the data storage of Snowflake. You can do that by manually uploading, or you can write that through an API, or you have that data in AWS storage or Google Cloud or Azure. You can bring it there to the data storage of Snowflake, or you can also upload from your local computer. After bringing your semi-structured data here, you can do pre-processing on that data using variety of languages, as we already discussed, like Python, PySpark, and SQL. Using any of these languages, you can pre-process your data. You can clean your data. You can convert your data into structured one and save the data into the tables. That is in compute layer. Here, the compute layer can spin up multiple independent virtual warehouses so that you can access your data concurrently. There will be little delays, and it process your data in an efficient and it is very faster way to do that. And compute layer has lot of features. I mean, to process your data, Snowflake is providing lot of features. And we are going to talk about two such things in today's class offered by the compute layer of the Snowflake for JSON data, that is semi-structured data. Most of the semi-structured data will be in JSON. If you ask me where this semi-structured data comes from, all the apps you're using on your mobile phones, on servers, they all produce semi-structured data. When you make a search in Google, when you write a review in Flipkart, or the data coming from your smartwatch, every data will be in semi-structured one. If data is coming in real time, it is event data, it will be in JSON. If data is coming from an APIs, it could be in YAML or XML format, whatever it is. All these are examples of semi-structured data. So today's storage solutions should be able to store and process the semi-structured data. And one of such popular storage, Snowflake. Let us get into the practicals. Coming to the compute layer, we are going to talk two such features on Snowflake. Using that, we can efficiently handle our semi-structured data. Those are variant, okay, let me type in here, variant, and one more thing is flatten. Let us talk about these two things. And we have one more layer here, cloud services layer, to interact with the compute layer. We need an UI, user interface. That could be from Snowflake SQL or any infrastructure manager, any kind of things. This layer, cloud services layer, allows authentication, ensures that users use right password, username and login, access control. You can grant permissions to multiple users who are using the Snowflake. So in Snowflake, you can store a lot of data. Maybe all the persons in your organizations need not require access to all the data that is stored in the Snowflake. You can control the access by providing them permissions or policies, and you can set authentication, and you can interact with the compute layer underneath through this one. Okay. Today, our things are going to be like this. So this one is actually Snowflake SQL. We are going to make use of Snowflake SQL. This layer, which I have on my local environment on my laptop. I have installed. I have Snowflake SQL. I have it. From there, I'm going to interact with the data which I am going to put in. Let me put it over here. Here. I'm going to upload data directly from my local. That is some IoT data. Okay. This data, I'm going to flatten. You can apply a lot of transforms to this data. We can talk about numerous transforms. We will talk about this feature called flatten for semi-structured data. So local data. And here in compute layer, what kind of compute we are going to do? We are going to write our data into something called variant. And then from there, we are going to flatten our data. So this is going to be our things, architecture, which we are going to do. First thing is you should get ready with Snowflake SQL. Using that Snowflake SQL only, we are going to upload the data into the data storage layer. After uploading data into the data storage layer, using SQL, we are going to flatten the data. And the flattened data, again, we will save in the Snowflake itself. All these stuff we do with Snowflake SQL, which is like CLI. Let me clear off this. As we discussed, Snowflake can handle structured, semi-structured, and unstructured also. CSV and data extracted from relational databases, JSON, XML, AVRO, Parquet, these kind of data formats can be efficiently handled by Snowflake. Unstructured data you can also save in Snowflake. Just give me a minute, guys. Right. Before getting into the Snowflake, we should understand few concepts about the Snowflake. We will start from storage layer. In storage layer, we have these things: stage, table, schema, database. Let me take you to the Snowflake. Okay, this is my Snowflake account. And you can see here, I'll click on create. You can bring your data. You can connect to Git repositories, Streamlit applications, and you can create a new table, stage, view. Let us start understanding from table. Table, we all know. Sorry, my screen has been paused. You see here, this is my Snowflake homepage. Here, if I click on create, a drop-down shows many things: SQL worksheet, Python worksheet, notebook, Streamlit app, Git repository, so many things. We will focus on these three guys. Table, right? When you create a table, you know what you'll get. You'll get rows and columns. If you want to load your data directly into a table, if your data is structured, yes, you can start off with this. No, you are not sure about the structure of your data, then create stage. You can create Snowflake managed stage. You can create Amazon S3, Microsoft Azure, Google Cloud Platform. From any of these storage solutions, you can create a stage. Stage is the place where you can bring in data without actually bothering about structure of that data. You can bring in JSON files, XML files, all the semi-structured files, unstructured files, you can bring to stage. When you bring in data to table, that data should have a structure. It will, according to that structure, Snowflake will arrange data into tables, like in a database. If you are not sure about your structure, if your data is semi-structured or unstructured, you can bring in your data to stage. Stage is the place where your data will be as it is. And view. You can create view of your data, which is like a temporary copy of your data, which stays in memory. It's not a permanent table or a permanent copy of your data. That is view. You can create views. We have these options. That is about the storage. Now I'll just go to bring in the data. I'm going to install this NoSQL. I already installed it. So from this page, you can install SnowSQL. SnowSQL is like a CLI. It allows you to communicate, connect, and also query your tables and the files in the stage, Snowflake stage. Okay, from this place, Snowflake, it's an installation guide, Snowflake CLI, SnowSQL. So you can installing Snowflake CLI. You can follow this. I already installed the Snowflake CLI. I'll log into that. Just have these commands here. To log in, I have to say SnowSQL and then my account identifier username. Login. My account identifier and username. And then it will ask password also. For these, I'll go to my Snowflake home. And here on the left bottom, I have my name, account admin. So whatever name you give while creating your Snowflake account, you will get it here. And also you will be choosing one cloud, AWS, Azure, or GCP. You may use it or you may not use it. You have to just select one cloud. I have selected AWS. Okay, using these things, I'll click on view account details. See, my account says AWS because I have chosen AWS cloud as an underlying storage. But I can also use Snowflake storage directly. I'll just click on view account details. And here I have this account name, account identifier. Actually, I have to use this account identifier. Even though it says account name, I have to say account identifier details. Pop from here, go to my terminal. Sorry. And username. Go back to my Snowflake home. My username is this one, 360DigiTMG, all caps. Copy. Put it here. Password. Right now, I have got connected to the Snowflake platform, cloud platform, where it has storage, compute, and also the cloud services. It's a cloud-based data processing and also data warehouse solution. But here I was not having any database, no schema, nothing is there. First, I have to give these details before uploading my data. Let us do that. We will create a data called a database called IoT Factory. I want to make use of this JSON data. I'll just open it. We'll have a view of that data. Okay, this data is like this: temperature, vibration, power, device ID, timestamp. It's a JSON data. And you can see the telemetry data. Telemetry data is nothing but the records. Each record, when it has multiple attributes, that each record of data that is continuously coming. In short, it's a measured data. Temperature, power, device. The sensors are measuring them and continuously sending. These kind of data we call telemetry data. It's a telemetry data, semi-structured data. It is arranged in key value pairs. That means it's a JSON data. Okay. Now I want to load it into Snowflake. Okay. If I want to do that, sorry, here, it's table is not the right solution. I have to put it in stage. But here, when you create a stage, you should also attach a table to it. When you upload data, you will upload into stage only. But every staging solution, storage solution, will have a table attached to it. When you convert your semi-structured data into structured, you can load that into the table. Here, tables will not strictly validate the structure. According to that pattern, they will accommodate the data into the tables. So every stage should have a table attached to it. So first we have to create a database. Table is nothing but database. And then we will create stage and upload data. Okay. Go here. I'm going to create the database called IoT Factory. See, IoT Data Factory successfully created. And you can also see my database now is IoT Factory. Schema is public. And then I'll say use this database and also replace the schema as sensor data. By default, we will get schema as public. We will replace this schema as sensor data. Enter. Okay. You can see my schema sensor data successfully created. And also you can see here it has been replaced also. What this thing tells to us is whatever we do here, that happens within this database right now. But I really don't want to make use of database because my data is semi-structured. It has IoT Factory database, sensor data. I want to save, I'm interested in saving the file as it is. So what I'll do, I'll create this thing called stage now. I cannot directly create stage. First, I have to set up database and then only we can create stage. Now, I'll create the stage. We'll call it as IoT stage. And this is the place where I'm interested to save my data because my data is a JSON file. I want to upload my file as it is. I don't want to put it in database first. Enter. Stage also created and this stage is attached to this table. You'll not see your stage details here. You'll see only your database and schema. But you know that IoT stage is attached to this database. Okay, we created the stage also. Now, I'll put the file. I already logged in, so I'll just say need not use this NoSQL -q. Directly, I can use this put command. Put up to this copy. See this command, put file IoT data.json is the same thing. Before that, first you have to check your directory. It says Flipkart folder. Let me go and check the same thing. IoT data. Yes, it's in Flipkart folder. Okay, come here. So I can directly use the file name because anyway I'm in local to that folder. Otherwise, I have to use the complete path. @ of IoT factory. Yes, IoT factory is my database name. Sensor data is the schema name. And the stage, we know it is IoT stage. We are compressing the data. Auto compress equal to true. Whatever compress Snowflake use, we are compressing that data and uploading into the Snowflake stage. Yes, it was done. You can see source. Source file is IoT data.json. We know that. We have with the same name, IoT data.json. Now target in the Snowflake, in the Snow stage, which we named as IoT stage. In the IoT stage, it has been compressed IoT data.json.gz. Source file, target size, and you can see target compression is gzip, source compression. Here I don't have any compression in my local. In the target, that is in the IoT stage, which is Snowflake stage area, it is a gzip. Status uploaded, done. Now we are interested in arranging this data into table. Why? If I want to query my data efficiently, I have to put it in the table. First, I am interested to bring whole data in raw format and then put it in table. So I have not directly put my data into the database. Now we will load it into the table, into the database. For that, we will create a table. This is important. Create or replace table. And that table is called IoT raw, as you can see here. And here we are using variant. I am not defining my structure of the table, which we also call schema of the table, because I don't know. It's a semi-structured data. I don't know the exact structure of the data. In such scenarios, we can use variant. Variant is a Snowflake feature. It's a native flexible type that loads all of your semi-structured data into a variant column. That means you're equivalent to, you're bringing all the data into one column. And according to the data that is available there, Snowflake will try to create a table. So easy, right? You need not worry about all the attributes and bother about selecting the primary keys. Even in NoSQL databases, key value type of databases, you have to know at least a primary key. Now here in Snowflake, if you don't know anything about the data at all, that's fine. You just use variant. Variant stores all of your semi-structured data. And then you can load it into the table. So we were creating a table with just one column variant. And all your JSON data will be in that column. Enter. IoT raw table has been successfully created. Next, we will select from the table and see how our data is. It's not showing it. IoT raw table. Okay, let me check here. We will copy the data into the table. Copy into paste it here. See, I'm copying into the table IoT raw. That is a table. We created IoT raw. IoT stage and IoT data.json.gz. Yes, those are the names. Yes, that is the name. And there is a file name in the IoT stage. That is a stage name. And file format type equal to JSON. Enter. Yes, now you can see errors. No errors. Rows loaded. 100 passed. 100 loaded. Now again, select everything from IoT raw limit 5. Now you can see the things. Yes, device ID, mission 2. The table is showing you data like this, but in fact, in reality, our raw data, I'll just go and open it once again. This is our raw data. It is like this. What is happening here? They are not arranged in a proper array-like structure. Here, temperature value is there, vibration, and then value is there. Power is a key, and it has a value. Device ID is a key or attribute name. It has a value. Now, if you try to load this data into any table, what happens is the entire line, you see the entire line, one record of the data goes into the table, into the one cell into the table. Okay, just give me a minute. Something happened here. Yeah. We don't want that. This is semi-structured file, but now we want to break down. We want to observe the structure that is available and write into the structured tables. But looking at this, I know that when I write it into the table, all of one cell in a table is going to take the entire thing. It's not going to split out the attributes. Temperature in one cell, power in another cell in the table, device ID in another cell in the table. I want to write in that way. I want to break down the attributes. And how we can do that in Snowflake using flatten. Now we are going to flatten the data. Paste it here. See, I'm going to create a table. Now, the IoT raw table, it's just having one column called variant. That variant has all this data. Now, I am going to create a table which has these many columns: device ID, temperature, vibration, power, reading time, all as separate columns. And how we can do that? Who is going to do that is a feature called flatten. Just you bring your data into variant and you say create or replace, and now you know the attributes that are available: device ID, power, temperature, timestamp, vibration. When you have the raw data, you don't know exact schema. So you loaded all the data into the variant. Now when you view the variant, you know that this is the structure. Okay, I can use this structure in the table. So we are creating a table, right? And we are creating a table from IoT raw and calling it as IoT flatten. Name can be anything. You need not use this name as flatten. Name can be anything. But yeah, when your data is in variant, when you try to copy the variant data, variant column data into multiple columns, it will work. So that feature of Snowflake is called flatten. Enter. No, I'll just run it once again. Flatten new. Okay, now I'll just go and check the data. Yes, you can see here. It says 1 rows produced, but I don't know why it showed like this. No, but not 1 row. You can see now the difference. This is the data which we have. Initially, we have the data as zip, where in staging area or stage of Snowflake, you can save your semi-structured files, unstructured file as it is here in stage of Snowflake. Now I know my data is JSON. It has some structure. According to that structure, I want to arrange it in tables. And the easiest way in Snowflake to do that is loading your data into variant, and we have done that, right? Just we have said variant. And this is how data looks like after bringing data into the table, but using variant. Variant data type. It's a data type. Variant is a data type in Snowflake, a special type of data type. All your data is there here. Now you will view your data, you'll understand the attributes. Now you will bring in data from this table to another table. For this table, you have created, you labeled the attributes and the data types properly. And finally, this is the output. Now your data is having a structure. You can apply your SQL queries you can apply better transforms when your data is like this. Yeah, that is about variant and the flatten. variant data type, and the flattened feature of Snowflake case. Hope you have enjoyed the session. Thank you. If you have any doubts, you can please ask.